Hello and welcome, and thank you for being here today. I'm Owen Hurst from Kerwell Media, and I'm joined by Guillaume Lavoie from Pilz Canada. So we'd like to both say, thank you. Guillaume is here. He's the project manager and senior technical sales rep at Pilz Canada. And I've had the pleasure of working with Pilz and have met Guillaume over the last few years, and we've crossed paths a number of times. And most recently in Meet at Moncton, where Guillaume was out there representing Pilz and speaking with a number of people there. Today, our topic of discussion is IO-Link safety, transforming the future of safety communication in diagnostics. With manufacturing companies moving to Industry 4.0, data on the floor is becoming increasingly important, and IO-Link has been great success in reducing installation costs, providing great flexibility, and increased data to the user, and making the communication very universal. Guillaume will today explain how the new IO-Link safety standard can help solve many pains in the new modern facility by increasing available data and decreasing installation. Guillaume is well placed to discuss this, having been a product manager at Pilz since January 2023, but he also has about 20 years of experience in the industrial automation industry. He has worked for German industrial automation companies in Canada in both sales and technical roles. And in recent years, he has been supporting customers in implementing IO-Link technology within their systems. Now, just quickly before I pass it over to Guillaume, just a couple of quick housekeeping issues. If you look on the side of your screen, you will see that you do have a control panel there. Just to let everyone know, the control panel will allow you to ask questions. So you'll see a small section where you can ask questions. We please encourage you to ask questions throughout the webinar as any of them come up, and I will be happy to jump back in and ask those of Guillaume before he moves on. Also, we will have a small Q&A session at the end, time allowing. We will attempt to turn the mics on and allow you to ask questions directly yourselves. So we'll hit a button that allows you to turn your mic on, or if you're more comfortable, please feel free to write it in and I will ask that for you. On another housekeeping note, we will be recording the session and we will be making the recording available to you and more broadly. And with that, let's pass it over to our expert and dive into the future of safety communication. Guillaume, over to you.
Thanks, Owen. Well, thank you for everybody that's attending. I see that there's a good amount of people joining in. So we'll go through the what IO-Link is a little bit. We'll do a little introduction to IO-Link itself, just in case anyone is not familiar with it. But we're going to be spending most of our time on IO-Link safety. So just to start a little bit, the first thing that I generally like to cover is what does the user and the installer want in an industrial facility? Like, what are the questions that they're asking, the problems they have? So everybody wants an easier installation. They want to spend less time on wiring, because the more time you spend on wiring, the less time if you're an OEM, the less time you have on your plant floor, because you're using that space to do the wiring. You want to simplify the configuration of your devices, because if you're spending a lot of time configuring, again, your machine is not being set out. If you're an end user, if you have to rewire something because something failed, that increases your downtime. If you have to configure something that you're replacing, again, that increases your downtime. So you want to reduce that complexity. The next thing people want is flexibility. When you select a product, if that product can be used in multiple places in your plant in different ways, that reduces the number of part numbers that you have to keep in your stores. It reduces the complexity of planning your next machine. So they want flexibility, but you also want to be able to select more of your components. So you don't want to be stuck with one vendor. You want to be able to pick any vendor that makes the best product for you, right? You want to reduce the downtime. I sort of mentioned that. By reducing the downtime, you're going to have a more throughput from your machine. You're going to have better reliability, and to do that, you need reliable components. You need more diagnostics, so you can predict what will potentially take down your machine or create a stoppage. And you want to make the replacement of the components easier. So if a component needs to be replaced, it's you don't need to spend hours on training someone on how to replace that component, because a machine will have thousands of components. You can't be an expert on every component that's there. And in the end, everybody wants to reduce cost. The lower the cost is on the on your machine or running the machine, the better you have. The more money you have in your pocket, right? So cost of ownership includes, maintenance, replacement, uptime, and so on. So really, everybody wants to reduce cost. So the question is, okay, what do we have right now, and what does it look like, right? So when we're talking about safety, traditionally, it looks something like this, right? You have you'll have all your safety components, and then they typically go back to one main control cabinet, being controlled by a safety PLC, safety relays, programmable relays. But so that actually works very well. It's been used for a long time. And it's pretty universal, right? You can, if you have an e-stop from manufacturer A and a relay from manufacturer B, they generally work together. So it's pretty universal, and it's not super complex as far as how to understand the connection, right? You have two contacts on your e-stop. There's not much there. It's simple. However, when you're doing that, you're going to have really long cable runs. Anybody that's seen a machine will know that cables are often one of the first failure points in a machine. So the longer your cable is, the higher the likelihood is that you're going to have a failure point on your machine. If you run a longer cable, you're more likely to increase the amount of noise that you have on that cable, which also means more chances of having downtime. And if you're running everything back into the control cabinet, what you're going to end up with is a big stack of cables, which, while the cables are simple, the wires are simple, you have a lot of them. So you have to sort through all these cables to figure out, okay, where's that e-stop that's not working, or that door switch that's failed. So you have a lot more time to diagnose, even though it's a relatively simple wiring scheme, right? The other thing we have is, typically when you're running everything back into a control cabinet, you're going to have terminal blocks. So terminal blocks, again, they're easy. People know how to use them. They're centralized, so if you have a failure point, it's all in that one cabinet. So that's nice. You'll have one place to look. But one thing that's a problem is that the terminal block, or the termination point, is not necessarily where the sensor or the safety device is. So you may have to have two people running back and forth trying to find that problem point. Terminal blocks are cost effective. They're not expensive. So those are some of the good things with terminal blocks. Now, terminal blocks also are very time consuming. When you're wiring, you can spend hours wiring wires into a terminal block. It's very easy to take that one wire and put it in the wrong terminal block and end up having a machine that's not running, especially with safety, because often one wire can mean the machine running or not, because you're maybe shutting off all the power to your machine because of that one door switch. So if it's not wired, the machine doesn't run. So that can really reduce your machine uptime, and it slows the troubleshooting. And then you need more space for terminal blocks. You're going to need a bigger cabinet, because you're going to have a lot of wires coming into that cabinet. Next thing is diagnostics, right? So everybody needs diagnostics. People ask for diagnostics. Currently, every safety manufacturer I've seen have their own proprietary solution to do diagnostics. So SDD, Safety Device Diagnostics, is the Pilz solution that we currently have. What is nice with this is it's relatively low cost to implement. You're using standard sensors, so you'll have your coded door switches, your interlocks, and so on. They're all going to be connected in series, right, through these Y connectors. Then you send a single dual channel, it's a dual channel input into your safety controller. And then you have a diagnostic line that's running in parallel. That diagnostic can be sent to your PLC, and then you get deep diagnostics into your safety circuit. So you'll be able to know, are all my devices connected? How many faults have I had? And so on. So it's a good solution. It'll gives you all the diagnostics you need. Uses existing safety concepts, or you're using standard signals. So it can be a Pilz controller, but it could be somebody else's controller as well. You just need the diagnostic unit to get those diagnostics out. However, it is proprietary, so you can only put Pilz products in series together. You can't bring in somebody else's components. So if you're using somebody else's I don't know, safety scanner, and you prefer their product, you can't bring it into the existing series connection. So you're going to have to create a new connection. And so it does limit your choices, right? And then configuration is another big thing. Any device that you have on the plant floor that's proprietary, or not proprietary, that is configurable. So think in this example here, we have light curtains. If you're using our advanced light curtains that give you a lot of functionality as far as muting, blanking, floating blanking, so cascading, etc., you need to use our software to configure that light curtain. Now, the good thing with that is it works out of the box because it's designed specifically for that light curtain, so it works very, very easily. However, if you have a mix of manufacturers for different components, you start having a long list of software on your laptop that you have to maintain. We all know that with IT and security these days, installing more software becomes more complicated. You have to get the permission from IT to add the software and so on. So it adds complexity. So we want to reduce the number of proprietary pieces of software that you have to use. So with all that being said, a lot of those problems are driven right straight into what a lot of people are talking about these days, which is Industry 4.0 and IoT. So really, to understand what Industry 4.0 is, you really need to know what Industry 1.0 is, which was really when the first mechanical weaving loom, the first machine that was producing a product, came into in the market. So in 1784, there's a lot of companies in the Canadian market that are still in Industry 1.0, and that's fine. Sometimes it's all they need. Industry 2.0 is when conveyors came into the market and linked those machines with conveyors, increasing the efficiency of the production. Industry 3.0, I would say, is where a lot of our core customers are where you have really robotics, automation, PLCs driving that manufacturing process. And then what is Industry 4.0? Well, Industry 4.0 is taking essentially everything that you have on in the plant. So your machine, your conveyor, the data generated by all the devices, and bringing them into a centralized platform so you can look at your data and make smart decisions, right? So the more data you have, the smarter decisions you can make. So you can determine that, hey, we know this particular component tends to fail after a certain number of hours, or when a certain number of a certain vibration pattern comes in, we know that product may be failing, so you can make a decision to replace it before it fails, and not take down your plant unexpectedly, right? And then what is IoT? IIoT, because when you're talking about Industry 4.0, you need data. And where do you get your data? Well, it's going to be from your controllers, your connected devices. But IIoT is taking the devices that traditionally are not smart, don't have communication, and giving them communication. So if you're talking about IoT on the commercial and home world, you're talking about smart lighting, smart cameras, the security cameras, things like that. In the industrial network, we're talking about sensors, which typically sensors had smarts, but they didn't have a path to communicate other than, hey, I'm on or off. It can be valve actuators, robots, all drives, all those devices, giving them communication. That's what IIoT is. So with IIoT, basically what people are doing is giving more communication to all their devices. This is just a little chart coming from HMS Networks. They do an analysis of the overall networks, industrial networks in the global market. And what you'll see is a lot of the market is now covered by Ethernet networks. Ethernet networks are great because you can push a lot of data through it. It's very quick. People use it for a lot of other applications. Our laptops are connected through Ethernet. Everything is connected through Ethernet. So industrial Ethernet networks are really important. So typically we're talking about Profinet, Ethernet IP, EtherCAT, Modbus TCP a little bit as well. So those are important networks. Now, when you choose an industrial network and you want to do safety, then you want to choose a network that supports a safe communication. So the three major ones on the market right now are ProfiSafe, SIP Safety, EtherCAT. Overall, how do you choose the network? It's usually driven by the PLC you've chosen. You may choose a PLC because of the platform, maybe because of who your programmers, what they know how to use. Could be because your customer has specified that, hey, I have to use Rockwell in my plant. Once you've picked that controller, then you're sort of stuck with the network that PLC platform uses. So, in North America, we're typically looking at SIP Safety, a little bit of ProfiSafe on the network. So to get those safety devices connected in an IoT way, you do need communication. And that means that the safety manufacturers either create more expensive components that support SIP Safety, ProfiSafe, and so on. And they also have to create specific components for the specific networks. So you may have a manufacturer that only supports ProfiSafe because that's their knowledge. They have a great product, but it just doesn't work with your PLC. And that's a problem. You want to use the best product for the application. So that takes us to IO-Link Safety. So IO-Link Safety, what it is really it's a vendor neutral communication protocol. You'll see on this slide all the members as of last year. I haven't updated the slide in a little while, but you can see that it's not just a Pilz network. It's not just one manufacturer. Really, you have a large number of companies that are really supporting this. So what that means is you have really the support of everybody for this market. Now, not everybody is using IO-Link Safety yet. This is really the IO-Link consortium. But really, the IO-Link consortium, the idea was really to create sort of a USB type communication for the industrial network. So if you can imagine, if you're old enough, you might remember that keyboards and mice had their own proprietary ports on a computer before USB existed. You couldn't plug in a mouse into a computer keyboard port. You couldn't connect a smartphone into your laptop to be able to communicate data. Every port was proprietary for one use. So it limited what you could connect. It also limited what manufacturer's product you could connect. So you almost had to choose the mouse that goes with that computer. So the Apple mouse did not work with the Microsoft based computers. That was a problem. So that's really what we're trying to do with IO-Link, is to create a vendor neutral communication standard. So IO-Link itself has been growing very quickly. So in 2022, it increased by 33%. as far as number of nodes. So it's really a fast growing network, not network, communication. And IO-Link safety is going to represent a huge increase in that market. IO-Link has never been a safety communication protocol up to now. It was really about sensors, actuators, IO connection, but not for the safety, the standard devices. So what IO-Link enables, what you can see here, the traditional connection, what you had is you had data going down to, if you were using distributed IO, you'd have communication down to the IO hub or master. And then all you had was inputs from the devices, right? So your light curtain was coming into the port. It's on when it's, the OSSD is on when it's safe. When it's not safe, it's off. You get no communication back to the light curtain to tell it which modes to use. Doesn't tell you the state of the lens, doesn't give you any feedback other than, hey, I'm good or I'm not good, So that's without IO-Link. So your communication sort of stops, doesn't go all the way down to the bottom. So what IO-Link looks like really is this. So first, you're going to have your control platform, your network. Your network can be any network you have. It could be a Ethernet IP, Profinet, EtherCAT, etc. And then you're going to have a master. So it's it's essentially a gateway. And then you'll have IO-Link communication. So it's point to point to a device. So let's say a sensor. So the sensor communicates in IO-Link. The IO-Link master captures that data and then passes it on to the PLC. This communication here is network neutral. It doesn't care if it's Ethernet IP or Profinet on the upper level. It's just passing its data over, and then the master is doing the gateway. So that means that these devices are universal. You can use them on pretty much any network that a master exists for. The other nice thing is you're using standard M12 cables typically. You can also use M8 cables, but it's a standard cable, so it reduces the cost because Ethernet cable is actually pretty expensive. It's a shielded cable. It uses 5 volt or 3.3 volt signal, and that signal, first of all, is because it's a low voltage signal, it's very noise susceptible. So you have to make sure that your communication cable is twisted pair, shielded, and shielded correctly, so your cost on that cable increases. Now, sensor cables, on the other hand, are relatively cheap comparatively. So IO-Link, because it uses a 24 volt signal instead of a 5 volt, the amount of noise that it takes to affect that signal is much more. So you can actually use an unshielded cable to communicate with IO-Link devices. The other thing you'll notice is the M12 pinout is pretty much something that you've seen before. It's the standard PNP sensor wiring. So pin 4 is your communication pin for IO-Link. You have pin 2 that can be an input or output, and then pins 1 and 3 are your power. Right? Now, IO-Link safety. So IO-Link safety was devised by the IO-Link consortium. It's been standardized in the IEC 61139 standard. So it's not just a proprietary thing. It's actually been standardized globally by IEC. It supports up to PLE, so the highest security safety level. And like I said, it's field bus independent. So as long as it's a safety network, you can support it. And what you'll see here is now you have, with the components that you'll have, I sort of mentioned that a little bit earlier. You have your PLC. You'll have your higher level network. Let's say Rockwell or RSLogix, SIP Safety in this case, or ProfiSafe. And then you'll have the IO-Link master and the IO-Link components. The other component here is the IODD. The IODD is essentially like a driver file. So every IO-Link device will come with an IODD file that sort of tells its capabilities, what address have what configurations, and what can it provide back to the PLC. So that IODD file allows you to import it into your controllers, your software, to know how to configure it. And then the cable, obviously. So what that means, oops, skipped one too fast. What that means is your data now goes all the way down to the safety device. So your safety device can provide feedback. Hey, my lens is getting dirty. I need to be clean, as an example. So that your machine doesn't go down. And you're not changing anything on the upper level of the network. This stays the same as it was before. And you'll see again with IonLink safety, not much has changed. Again, it's a 24-volt signal on pin 4. Pins 1 and 3 are your power. The one thing that's different is with IonLink safety, the standard has defined that if your IonLink safety device, let's say your light curtain, does not sense an IonLink master on the other side, it can switch into what's called OSSDE. So OSSD is a pulsed output signal for safety. OSSDE is a standardized pulsed output signal. What that allows you to do is to configure an IonLink safety device through a USB adapter with your laptop, and then install it with standard safety relays or a non-IonLink safety controller. You still have 20 meters max of cable between the IonLink device and the master, so that can be up to 20 meters, and you still get 32 bytes of data, which is something that's IonLink has been supporting. So it's 32 bytes of input and output data. That's a lot of data for a sensor typically. That's per IonLink device is 32 bytes. So what is OSSDE? That's an important standard. So it's basically OSSD hasn't really been standardized 100%. There was a ZVEI standard that was, or a paper that was written. So some manufacturers do follow that paper, but not everybody does. So every once in a while you have an OSSD device that is not supported by the controller that's being used. So OSSDE is now a standardized signal, so that should allow more devices to be used. Again, if you're not using the IonLink communication itself, but just configuring and then putting it onto a safety controller. So something like this, where you have a USB adapter, you connect it into your laptop, and you use whatever software. So in this case, it can be the Pilz software, but it could be somebody else's software. You just take the IODD file, you load it into the software, and then you can configure the device. So that reduces the number of pieces of software you have to have installed on your computer. So if you already have somebody's software installed for IonLink safety, you can take the IODD files for our device, put it in their software, and configure it. So gives you a lot more flexibility there. So talking about all the IonLink safety is really what does IonLink safety, how does it differ from IonLink, right? So IonLink is a standard communication. You have 32 bytes of data for communication. What does the IonLink consortium specify for IonLink safety is really the black channel. So the black channel is a principle that's actually used in all the current Ethernet network platforms. So SIP safety, ProfiSafe, FSOE, they all use the black channel principle. Essentially, it's a priority message with error detection, right? So what you'll have is a verifier record. So basically, it's going to be looking for the identity of the device. So if a device was plugged into port 1 and it's moved to port 2, it should detect that. It should detect the number of devices they have and the data structure. So if you've configured a device to provide a certain amount of data and all of a sudden it's not providing that data, then there's something that's going on, and the verify record will detect that. And then you have other safety measures like numbering of the messages. So there's actually a sequence of numbering that the iONIC master and the iONIC safety device are going to be exchanging. So it's almost like a sequential 1, 2, 3, but I think it's a three-bit counter. And that if there was a mismatch in the communication, then we know that there was a communication error. So then it will trigger a safety event. There's also time expectation. So we know that we expect to have that information back from the master or from the safety device within a certain time. If that time increases too high, there's going to be a timeout and the system will safely shut down. So again, making sure that your system is safe. So if somebody cuts a cable, communication stops happening, the time expectation will elapse and then it will stop. And that happens very quickly. You also have authentication. So it's actually going to be on power up, going to verify that the right devices are connected to the right ports and so on, the correct ID, device IDs and so on. And then you have the CRC check, which is again something that's you'd be familiar with if you've ever done any a safety communication like with Rockwell with a Rockwell PLC. You're going to have to create a CRC code from your devices in the field. Looking at the data, one of the things that's interesting is really how your data will look like through iONIC safety. So it's very similar to standard iONIC. However, we do have to reserve some of the data for the safety communication. So you have up to 32 octets of data, and then you have 2 bytes, 2 to 4 bytes for the signature. You'll have 1 byte for the counter. You'll have 1 byte for the port number, and then you have process data, which is between 3 and 25 bytes, and that gets you your 32 bytes. And same idea on the data coming back. So your 32 bytes of data is specified. For an iONIC safety device, we'll have a little bit of data that's always reserved for that safety communication. So I was talking about terminal block wiring earlier, and that was costly. The general industry average for wiring a wire into a terminal block is about 8 minutes per termination. So that includes stripping the wire, maybe putting a ferrule, inserting it into the terminal block, but also checking that you have the right wire color, checking the manuals to find that wire color in the manual and so on. So all that typically costs about 8 minutes. Typically that 8 minutes is handled by an electrician, so that you can do the math of what that 8 minute costs you. So how much one wire costs you in the plant. If you go to so something as example here where we have the Pilz pit gate box, which is it has an e-stop and 3 buttons to request access to enter a machine. That has a M12 12-pin wire. So 12 wires at 8 minutes each. You have 96 minutes just to wire this one device. If we compare that to what you'll typically see with an iONIC solution, which is typically M12, you're going to be less than a minute. Typically, we say a minute. It can be seconds sometimes to wire up that same device. So you're saving a lot of money on your startup, also on the replacement. So if the cable breaks, you just unplug that cable, plug a new one in. It doesn't take much time. And then because you typically use a distributed I/O block, that block is closer to the device. So let's say you had a gate, the gate access box and the network block are going to be pretty close. So if you need to replace that cable, typically, yeah, you can go up to 20 meters, but most people are using 2-3 meters. So that cable is easier to replace. It's not a long 100-meter, 200-meter cable that you're fishing through cable ducts into the ceiling and so on. So that reduces your downtime when a cable fails or if you need to replace something. So one cable, less than a minute. So now we've talked about what IO-Link is. Hopefully it's relatively clear. Feel free to ask questions if I missed anything there. And now I'm going to go over a little bit of a preview what's coming to the market from Pilz on safety products, IO-Link safety products. So we're working on a complete solution for IO-Link safety. Owen, was there a question?
Yeah, just want to jump in real quick there. When did have a bit of a question that came around the breaking of the communication cable and stuff. What do you get triggered a message to notify you when something like that happens, or if it is like a break in the cable? Do you, how do you run down and find out that it's that the cable is the issue?
If it's the cable, you're going to lose communication to the device. Now you won't know if it won't necessarily tell you, hey, it's the cable or the device, but you'll lose the communication. So that it'll pinpoint to a good direction of where it is. And since it's not a network, you have one device and one cable. So it's down to two things at that point, because you lost communication to that, I don't know, that interlock. That interlock is not communicating anymore, so it's either the interlock or the cable. So it reduces the complexity. Now, if you're talking about a larger network where it's an Ethernet cable that fails, that Ethernet cable can take down half of the machine because one cable failed. So that's more complicated. But with IO-Link, because it's a point-to-point communication, it's pretty easy to figure out, was it the cable or the device? Replace the cable. Does the device power back on? No, then it was probably the device. So
Gotcha.
it simplifies. Yeah.
And actually, a question following up on that: if it is the device and you need to replace the device, what happens to your stored parameters?
So that can be done multiple ways, and it really depends on how you implement the platform. So you can either have the data stored on the PLC, and then trigger the configuration to be sent down to the device. You can plug it into your laptop using an adapter, and then configure the device. Or and this is one thing I have to look, because I don't have all the products in hand yet, but typically with IO-Link devices, you actually have port memory. So the IO-Link master might even have memory in the port telling you what was connected there and how it was communicated, configured. So it really depends on how you implement it. The great thing with IO-Link is it's giving you the choice to implement it the way you want. You can, and a lot of people will just use it as a communication path. They don't configure anything. They're really just using it for because the cable's lower cost, the communication is solid, but that can change.
Of course. Just as I'm asking that, there's another one coming in. Is there a plan to add CIP safety communication to the IO-Link block?
So for the plan is yes. The answer is yes. That's the plan right now with Pilz, and I'm going to hit that very soon. And like one of my colleagues likes to say, stay tuned. We'll talk about the IO-Link master. We're starting with ProfiSafe. Actually, in the IO-Link standard right now, only ProfiSafe has been defined. The majority of the manufacturers that are working on IO-Link safety currently are in Germany or in Europe. So, and ProfiSafe really holds the market over there. So that's where it's starting, but SIP safety will be coming, and I would expect EtherCAT Safe FSOE to come as well. So within Pilz, that's definitely a discussion, and everything that I've seen, it will come.
Perfect. Thank you very much. We don't have any more at the moment, so I'll let you continue on. Thanks so much for that. Cheers.
No problem. So coming in 2024, we're in 2024. So later this year, we're actually going to have 3 major products that are going to be launched. So first, obviously, the IO-Link master. It's an important component if you want to communicate. We'll talk about that. Next one is going to be our SenOpt 2 advanced light curtain. So our light curtain, IO-Link safe light curtains, and we're going to have the PIT gate box IO-Link that's coming. So we'll dig down a little bit on what those components are and what how they look like. So the first one is our IO-Link safety master. So what the IO-Link safety master will have is basically the top 4 ports will have standard safe inputs. So You can connect your e-stops, your traditional light curtains, your gates, so on. Dual channel input, standard safety inputs. The bottom 4 ports will be IOLINK safe ports. And I don't know if you can see it, but right in here, there's a little IOLINK logo like this. So those are the ports that are going to have IOLINK communication. Those ports will be able will be able to support the IOLINK safety components. But the other thing that I didn't talk about is in the IOLINK safety standard, the master actually supports standard IOLINK devices. So let's say you had an IOLINK smart light that has RGB LEDs, and you want to connect it, and you didn't have an IOLINK master close by, but you have an IOLINK safety device. Well, you can connect it into the IOLINK safety port. So it really gives you an option. So it's sort of what we call downwards compatible. So the ports are all going to be 5-pin M12, like we talked about. On the master here, you'll have a 2-port Ethernet switch. In this case, is going to be a ProfiSafe switch to start with. So you can do daisy chaining for the communication. And then the power is going to be provided by an L-coded M12. These are relatively new M12 connectors that are on the market, but most manufacturers that I've seen are starting to move towards that because it actually supports up to 16 amps. So it gives you a very compact connector with a lot of power. So that will allow you to really support all your outputs that you need. The block will be rated for PLE SIL 3. It's going to have a 20-year service life, pretty much like all of our other components. So really, it will be your middleman in the network. It's fully metal, fully potted. It's a really heavy duty device, so it will survive the industrial network very well. I sort of covered that a little bit. So you'll see the top 4 ports are the dual channel fail-safe inputs or outputs. They're configurable. And then you have your IOLINK safety inputs or standard input and outputs. So if you're not using the port, you can also use it as just a standard PNP input. And then here you have under the cap, I didn't talk about, we have a reset button. So if there was a fault, you can pop the cap open and hit the reset. We also have a port here that'll allow you to put a memory card so you can store all the parameters in the master. So that was sort of going to somebody's question earlier, what happens if you need to replace the components. Now the IOLINK components, those can be the configuration can be in the PLC, but this memory plug can allow you to store the parameters of the ports themselves for what is it in IOLINK mode, is it an input or an output, and so on.
Boom, you hit a couple points there because we had a bunch of questions roll in all at once there. So you got a couple. So what are the limits of daisy chaining those IOLINK safety masters?
Yeah, so for daisy chaining, as far as the communication goes, it's pretty much unlimited. It'll really depend on the PLC you have. So some PLCs have a maximum number of IP addresses or nodes that it can support. So that will be your limit. On the power side, well, you have 16 amps. Your cable is rated for 16 amps. So it's really depends on how much current you're drawing on each block. That will determine how many you can put in a single chain of the daisy chain. You can also do star. It doesn't have to be in a daisy chain. A lot of people prefer to just have a single block with a single Ethernet cable coming off of an Ethernet switch. So you'll have your Ethernet switch here, and then you'll just run a single cable from there, and you'll go to the next block. So then, if this block fails in the field, you're not taking down everything. That's a very, very common way. And then same thing with power. You can run separate power cables to the blocks, or you can pass it through for your power in and power out. So there's choice.
Gotcha. Timeline for Pilz releasing an IOLINK safety master?
So right now, the schedule is for Q4 this year to launch our products. We have the product is real. We were actually showing it at the Hanover trade show earlier this year. It's just the last little key points like approvals that need to be completed, and then we'll be launching.
Gotcha. And then final one is somewhat similar, but is there going to be 8 IO-LS coming?
That I'm not sure. For Pilz right now, I think the only master that I know that we're working on is this, and it will probably come out with very similar blocks for SIP safety and EtherCAT safe FSOE. 8-port devices will potentially come, but with this, it's still very early days, so there's no timeline specifically for that.
Gotcha. Okay. What about, is there a built-in web server to set up IODD files and parameters, or will there be a separate software for that?
We do have a built-in web server. I don't know the full functionality of our web server yet. Again, I haven't. I've held the block myself, but I haven't played around with all the parameters. There will be a web server. I know that you can do test the inputs and outputs. There's going to be something like that. I'm not sure if we'll be able to load the IODD in the block itself, but we are working on software to support the block. Actually, it'll be the same software that we already use for our other IO, our IP20 IO, which is the pass config software. So it'll just be an update to that existing software to support the new devices.
Gotcha. I know we've talked a little bit about wire distance so far, but had a question specifically with regards to large machines. What is the total distance in wiring that you can implement?
Well, it really, I mean, generally you're talking about 20 meters off of the or actually that's not the iLink port. The iLink port would be here. So 20 meters from here to your device, right? And then, whoops. Sorry for my bad handwriting. And then you can do another 20 meters that way. So that, technically off of this block, you can go, 40 meters one side to the other. But typically what people are going to be doing with an IO-Link master is they're going to cluster everything that's sort of close to one block. And then you're just using the ProfiSafe, ProfiNet standards, which is basically 100 meters from an active device to an inactive device. If you have Ethernet switches with fiber optics, then that can be kilometers. It really so you can distribute that. So it really depends on how you set it up. But as far as the IO-Link communication itself, technically 40 meters from one device to the other at the most. But then you can move another block somewhere else, and that can be 100 meters typically if you're doing daisy chain, and then add another 20 meters.
Great. Will there be a version to talk to the Pilz Safety PLC?
Right now, our Safety PLC only communicates with Safety Net. I don't think we're going to work on a Safety Net IO block. But what is coming on our the next generation of our PLCs is going to be OPC UAFX, which is a new standard, and then at that point maybe. As far as our small safety controllers, we haven't launched it in Canada yet, but very soon we will have an FSOE communication card. So technically, you could take a FSOE IO-Link Safety Master and bring it into the small safety controller. You're sort of, because it's a small controller, it's not a full-fledged PLC, you're sort of limited on the amount of data you can bring in. So we'll have to determine if it really makes sense, but in theoretically it could be done.
Gotcha.
So we're working on that. But really the target with IO-Link Safety for now is really to work with the existing, the major PLC manufacturers like Siemens, Rockwell, Beckhoff, Omron, so on.
Gotcha. Yeah, no, that's great. I've got one more here for you. That's all right. Will replacing devices connected to Safety Link IO input break the safety PLC code signature?
I'll have to. I'm not sure if you'll have to do a reteach the CRC when you replace the device. I think if you replace like for like, it should be okay. But that would be something I'd have to confirm. I'd have to come back to whoever asked that question to.
Yeah, and we can definitely follow up with that individual and touch base with them after to ensure they get a full answer to that. So
Perfect.
at this point, I don't have any more come in. I know we ate up a good bit of time, so we're
No
and
problem.
yes, that they would like you to get in touch, so we will definitely do that. So I'll
Excellent.
let you move on now, as we do have just 10 minutes left.
All right, we got only a few more slides to go. So I think this we sort of covered really quick. Actually, here was sort of the question about configuration. So the passconfig, like I mentioned, is actually the software that you're going to be using. So passconfig already is used to configure our IP20 IO that we have available that for SIP safety and ProfiSafe, and then you'll be able to go into passconfig and configure the block there as well. Now jumping into the CNOP2 Advanced light curtains. So really, it's a extension of our CNOP2 light curtains. So we've actually been selling the second generation of light curtains for quite a while. What's great about those light curtains is they're very robust. They can handle 50 Gs of shock. They have a really no dead zone on the top and the bottom. And the shape of the light curtain is actually designed so that you can do sort of a cascade without creating any gaps. So you can really calculate your safety distance without adding extra gaps. So if you're taking a finger safe light curtain and you do a L shape, you can still do your calculation with finger safe. What the CNOP2 Advanced light curtain will give you is really bring some of the features that we had only in the CNOP Advanced, which is sort of an aging series of light curtains that we have. So it'll bring in some muting capabilities in L, T, and X style, blanking, floating or fixed blanking, reduced resolution. So basically you can mute, so you can get a finger safe light curtain and then turn off some beams if you want to reduce the resolution. And then single beam evaluation. And that's actually something that's really interesting because that will allow you to know which beam is cut. So as an example, an application that you could have is do smart muting where my box is that I want to pass through this light curtain is, I don't know, 200 millimeters high. I won't let anything bigger than 200 millimeters go through that conveyor. So now you can do some smart muting with the application. You can also know, hey, is this beam, are we getting some dirt and the receive power is dropping? So then you can trigger someone to clean the light curtain before it stops working. You can also know, hey, only the bottom beams are cut. Maybe something fell on the floor, so you can look at the floor. Oh, is there something on the floor that's blocking the light curtain? So you have a little bit more information. You know that it's not just an alignment issue. It may be something that's on the floor. So it gives you a lot more information. Yeah, there's a question, Owen.
Yeah, thanks. Yeah, a question on the muting sensors. So do muting sensors plug into the light curtain, then go back to the PLC over the safety IO link?
Yeah. So the emitter, or sorry, the receiver will have a 12-pin M12 connector. So it'll allow you to bring in your muting sensors into the light curtain. I don't know. I believe the muting sensor status will be sent over IO link, but that's something I would have to check. But definitely the muting sensors can be connected into the light curtain itself, and then you configure the muting type based on that. Actually, something that we launched this year that goes hand in hand with this is we have what we call the muting sets or muting kits, which includes those muting sensors. It includes some muting arms, so basically arms that can be mounted directly into the T-slot of the light curtain, so it simplifies the mounting. And then we have, and I don't have it in the presentation, but we have basically a distribution blocks that you can bring in all your sensors, your light curtains, so everything that you have connected, and then have a single IO-Link cable out to your IO-Link master. So that will reduce the complexity of wiring those those muting sensors. So that's actually available right now for our standard light curtains, and then it'll be compatible with the IO-Link safety light curtains as well.
What about with muting active beacons too?
Yeah, the IO-Link muting box does have a muting lamp output specifically for that. The muting lamp is not part of the standard, is not required anymore, but it's still a good idea to have. So we do support it on the muting box.
Perfect. Thank you.
So just sort of a quick recap. Since we only have 5 minutes left, we'll go a little bit quick. So you have live data on every beam. You'll have detail on the quality of signal, the internal temperature, so you can predict what may be taking your machine down and act on it before the machine goes down. So that means more uptime, better. So that means that your plant is more profitable. And because you, hit the button too quickly, because the parameters can be stored, you can replace those products very quickly without having to spend too much effort. This is sort of the we're going to be creating a software specifically for light curtains to configure it. You don't have to use this. You can use more generic software, but they will be available there. So I won't go into too deep details because we also have one more device that I want to talk about. Actually, there's the muting box that I was talking about. So you'll see your 2 muting sensors, your muting lamp, your override, your restart, all can be connected in this box, and that box can be mounted right in the T-slot of the light curtain. And this is in a mode that would be an IO-Link safe mode. So same muting box can be used either in standard mode into a standard, NOS Sigma safety relay as an example, or with our IO-Link Safety Master. And the last product that's coming out, and I'm the most excited for this product, other than the Master, is our pit gate box. So the pit gate box I talked about earlier, it costs a lot of time to wire right now. You have 3 buttons, plus each button has an LED. So that's an extra output that you have to wire. So then it's 12 wires. It takes time to wire. The IO-Link safety solution with this will reduce that time by a lot. But the pit gate box IO-Link safety actually has a little trick up its sleeve, which is this. So we're actually going to have 2 ports on the IO-Link, the pit gate box IO-Link safety. So one port will be your IO-Link safety communication going back to the master. So that'll handle all the buttons, the e-stop. But we're going to have an SDD port. So we talked about our diagnostics, proprietary diagnostics mode. That'll allow us to bring in all our existing devices that support SDD. So as an example, our PSEN code, our PSEN M-Locks, our M-Lock Mini that was launched this year, or S-Lock 2 that was launched this year as well. All those devices can be put into series with pit gate box. So what that means is that one IO-Link port can now support multiple devices. It can go up to 16 devices with SDD. The pit gate box will be device 1, so you can have 15 more devices connected to that one IO-Link port. And you can still get all the diagnostics that are existing in these devices. So as an example, error count. So I think that was one of the most important ones. So if you have a PSEN code that's chattering, you'll see that error count go up, and you'll be able to pinpoint where the problem is. And that is, we'll skip through that real quick because I know Owen's on the line because we're running out of time. And thank you.
No, hey, thank you. So, I mean, we got 1 minute, so maybe we just quickly whip off, but unfortunately we have had a bunch of questions come in. So
Okay.
Anyone who we do not get to, we will follow up. You will get a full response from us. So apologize, but just for timing. So first off, number of people have commented, fantastic presentation, Guillaume. Very well done. You were very, very good. So a couple of quick things. For the SDD devices, how many? Is there a limit?
There's 15. So when you were talking about SDD on its own, is 16 devices maximum per SDD master. When we're talking about the IO-Link safety SDD devices to a pit gate box, it's 15 plus the pit gate box, so the 16 again. You don't need that separate SDD module when you're doing it with the IO-Link safety pit gate box.
Perfect. And I'm going to ask this one question because I think you can probably answer it pretty quickly because we are at time. Regarding the safety devices, do you still use the standard sensor cables? Do they need to be shielded?
With IO-Link safety, it's the same. It's the same as IO-Link, so it doesn't need to be shielded. If you're expecting to have a lot of noise, then it's not a bad idea to shield it, but it's not required. Again, because it's 24-volt pulse, like 1 volt of noise on 24-volt pulse is negligible. 1 volt of noise on a 3-volt signal is a big percentage of that signal. So that's why you don't necessarily need to shield the cable. You're also doing a shorter cable, so the amount of noise that's induced in the shorter cable is lower. So not required, but you can.
Perfect, understood. So we are going to wrap it up here. I will answer the last question myself and saying, yes, we will be sharing the presentation. We will be sending out an email to everyone. So yes, you will get access to the presentation. And if we didn't get to your questions, we will get up. And now we're just having a number of people pour in and say, great job. So
thank you.
Fantastic.
Thank you, everyone.
Thank you so much for taking the time to go through us with everyone today. It was very informative. And again, thank you so much for your time.
All right. Have a good afternoon, everyone.
All right. Thank you so much, everyone, for joining us. Have a good day. Cheers.